When Nathan Oakley used arguments from fallacy to answer every single one of Professor Dave's challenges, Anthony Riley made a claim during this challenge that really shows the level of ignorance that flat earthers have when it comes to perspective.
I had somebody on my channel. He sent me a message and he says, Sleeping Warrior, I'll give you £1,000 if you can show me any picture or video of the Mourne Mountains in Northern Ireland from anywhere on the coast of England. Should be piss easy on a flat earth given a clear day. And I thought, Mourne Mountains. Let me go and have a little look at that and see how what the angular size should be. So I looked into it and I realised that it's just too small to see. It's not a big enough mountain.
Are you sure it would be too small to see?
So here's my response to him. It says, Dear MJH, this is the guy. I said, I've had a little look at this for you. Your claim is, quote, should be piss easy on a flat earth given a clear day, unquote. Assuming an earth with no atmosphere at all, just looking at the geometry in isolation, Slieve Muck, which is the name of the mountain that's near him, happens to be 674 meters high from sea level. It is 160,934 meters away from the English coast. This gives it an angular size of 0.2 degrees.
Now I know that unless you're blind, 0.2 degrees would be visible. So I thought maybe he made a mistake and actually meant 0.02 degrees, which is the limit of visual acuity for the human eye. So let's do a little bit of math here. This is the Mourne Mountains. Here is Slieve Muck down here, 2,208 feet or 0.42 miles. So I used Hoy Lake down here because I know both Anthony and Ranty Flat Earth have used this location for some videos to Blackpool. So Slieve Muck is 128.4 miles away. And that would be an angular size of 0.19 degrees. So yeah, Anthony's right. It's about 0.2 degrees. But here's the bigger mountain, Slieve Donard, 2,790 feet or 0.53 miles in elevation. And this is even a little bit closer, 124.6 miles. And of course, Slieve Donard is a little bit bigger in angular size at 0.24 degrees.
And if we assume no atmosphere whatsoever, it is possible. However, because the only one I randomly picked happens to be 674 meters high, it simply is not big enough to see, even with a zoom lens. It's just too small at 0.239 degrees.
Well, I think everybody is familiar with an eye chart, and if you have 20/20 vision, you can see down to 1 arc minute or about 0.017 degrees. So the visual acuity of the human eye is about 0.02 degrees. And since 10.2 degrees is 10 times larger than 0.02 degrees, those mountains would be visible to someone that didn't even have 20/20 vision if you had the right conditions. And are you serious that you wouldn't be able to see it with a P900? On the left, we have a P900 set at 55 millimeters, and this is about what the human eye would see. On the right, the P900 is zoomed in at 2,000 millimeters. Where is this structure in the photo on the left? It is within this yellow circle here. And look at the detail on the right. You can even see individual bricks. So yes, under the right conditions, it would be quite easy to see those mountains from Hoy Lake, and most certainly with a P900. Now the question is, what would we see on a globe and what would we see on a flat Earth? So what I want to do is make a scale drawing. Now this is the Google Earth view from Hoy Lake. This would be zoomed in. So here's Slieve Donard here with the yellow line going up. This other peak here is in front of that Slieve Muck. So I don't think you'd be able to see that mountain. But what I did is I made a drawing of this profile. So what I'm going to do is make a scale drawing. Here is my ruler over here. So Slieve Donard, 2,790 feet, and I've scaled it to this ruler from the horizon right down here. So let's go to the curvature calculator. Now in Hoy Lake, your typical elevation in that area is about 18 feet. Let's add a 5-foot tripod for a total of 23 feet. And at that elevation, the geometric hidden is 1.78 miles or 9,398 feet. So from Hoy Lake, the base of those mountains would be 9,398 feet below the globe horizon, which I've scaled into the ruler here. So the top of Slieve Donard from Hoy Lake would be 6,608 feet below the globe horizon. Now let's change these values to angular size. So let's start with Slieve Donard, which would be 0.24 degrees in angular size. And so I've added a ruler here, which is divided into tenths of a degree. And we have Slieve Donard at 0.24 degrees on this scale over here. So what is the angular size of the hidden here of 6,608 feet? That would be 0.57 degrees. So now all I need to do is move this scale ruler up, and here we have it, 0.57 degrees.
This gives it an angular size of 0.2 degrees. 0.2 degrees is a random number to you, I'm sure. So let's add something to help to scale it to help you.
So no, Anthony, 0.2 degrees is not a random number to me, because I understand that this is an angular measurement, or how big an object appears. When we have an object, we have two measurements. We have the actual size, which never changes, and we have the angular size, which changes with distance. But you are correct. Let's compare this to something that we know. And that would be the sun, that is 0.53 degrees. So this photo is not possible on the globe Earth. The top of that peak is just too far below the globe horizon. Even with looming, just to see the tip of that mountain, it would have to refract up 0.6 degrees. And that would take some very unusual atmospheric conditions to have that happen. But of course, on a flat Earth, not only could you see this with the naked eye, you could most certainly use your P900 and document this.
Even without any atmosphere whatsoever, it is simply too small to see because of something called perspective. With an atmosphere, something you can't already see still cannot be seen. I've explained to you fully why you're wrong, supported it with evidence contrary to your perception, and even done a little bit of maths, so it must be true, right? Will you now admit your claim is simply wrong and you have no idea whatsoever of perspective? Although it is close enough, it isn't big enough, despite your claim that it is. That's how to deal with a troll.
Yeah, and we know he's excluding perspective because he's giving you the values in feet and inches or meters, which won't change with distance.
Who doesn't understand how perspective works? Anthony, I'll give you credit that you did get the correct angular size for Slieve Donard. But to claim that 0.2 and 0.24 degrees is too small to see, and especially with the P900, please, that is just utter nonsense. And Nathan, yes, the actual size of an object never changes with distance. It is the angular size that changes. And if you don't know how to do these calculations, then you have absolutely no idea of how perspective works. Now here's another thing too, is that this photo here with the sun behind this peak is possible. So from Hoy Lake, the compass bearing of Slieve Donard is 297 degrees. And this is sunset from Hoy Lake, England during April, and on the 29th and 30th down here, 297 degrees. And in August on the 10th and 11th, 297 degrees. So again, this photo is possible on a flat Earth in late April or early August. And Anthony, I know you know this location in Hoy Lake. This is the Hoy Lake Lifeboat Station, because in the past you and Ranty Flat Earth have taken some videos from this spot right here. So Anthony, go out, take this photograph and collect that 1,000 pounds. But let me give you a hint. This photo is impossible because the earth is not flat. And I know we will never see it.